Well, how are you doing? This video is going to be called Why Weight is Only Conventional and Apparent. So put on your headphones because this will be a little bit of reading. Okay, I'm going to get stuck into it and not mess around. Okay, this is called Why Weight is Only Conventional and Apparent. When you weigh an object, you're only weighing it within the medium of air, which is a gas. If you weigh the same object in a different medium, then its final calculated weight will be different, i.e., water, honey, oil, etc. When rain falls from the sky, or you drop your phone or throw something that's a solid or liquid up in the air, it will come back down. The obvious reason for this is due to the fact that the surrounding air can't offer support to these things, as the surrounding air as a medium is less dense than these things, so they have to come back down. The only thing that doesn't is gas. The reason that gas won't behave like liquids and solids in the air is because the air is also a collection of gases. So any other gas will just intermingle with it, as all gases are unbonded, so the atoms, particles, molecules act independently of one another and all other things. So when people say that gas has weight or gas has mass, they are fundamentally misunderstanding the calculation of weight and the defining of mass, along with the natural behavior of gas. If weight is calculated within the air, then how do you define a downward weight to it? As it won't have a downward vector due to its natural behavior, and it is the medium you're weighing it in. Trying to weigh gas within gas is impossible. Air is the standard medium that all things are weighed in, and gas won't conform to a singular downward vector, so you must contain the gas inside a solid container to give it any kind of a conventional weight. How would you weigh water inside water? Why would you expect the water to behave differently than water just because you want to weigh it? Weight is the downward vector on a scales. So if you put a scales into a swimming pool, how would you weigh the water on the left side of the pool only? It's ridiculous to even think about weighing the water on the left side only. But you could weigh a stone or steel object on the scales that you place at the bottom of the pool, as they will be greater in density, so they will display a linear downward vector. What you wouldn't be able to weigh though is a ping pong ball, as that will float on the surface. So the ping pong ball is something that can't be weighed with that convention in the medium of water. You also couldn't weigh red wine that is poured into the pool, as it is a liquid. So even if its density differs from the water, it will still behave as a liquid. So just like weighing a gas in air, it's futile to expect correct positive results. Weight is based off of a singular downward vector, and it applies to all things that exhibit this singular downward vector force, but it does not apply to anything that does not exhibit it. Inertia is defined as a resistance to acceleration. So to resist a force, you need a force, and the natural resistance to acceleration is weight, as a car without weight, if it existed, can offer no resistance to being pushed. This means that all items and substances that exhibit inertia must also exhibit a linear downward force of weight, as inertia as inertia by definition requires a resistance. Mass is defined in a couple of ways. In physics, it's defined as inertia, but you will also find it defined as an accumulation of something. The original Latin word that mass is derived from is missa, and this literally means an accumulation of stuff. In today's world, most people define weight as mass times acceleration. So what they mean by this is that an accumulation of stuff is under the influence of a gravitational force of attraction, and this gravitational force gives the accumulation a weight. But this definition contradicts mass having inertia, as the force of gravity belief states clearly that mass is given weight by gravity, so mass is weightless. You can't define mass as inertia and as being weightless, as these two definitions contradict each other. These two definitions contradict each other. So, if someone wants to claim that gas has mass, then they will have to admit that gas has no conventional weight that they can attribute to said gas, as they can't claim that mass has inertia and still claim that gas has mass, as gas behavior does not exhibit inertia, so it can't be mass if mass is defined as inertia. The concept of mass is fine as a zero baseline for weight, as we can say something has no defined actual weight and call that mass. But then we can weigh this something in different mediums as a downward vector force. To elaborate, I can take a steel ball and call it a mass, giving it a description of weightlessness. Or I can then weigh the steel ball on a scales in air and in water, and then state that its air weight is X and its water weight is Y, etc. But when I proceed to do this with a ping pong ball, then I will have to state that due to the density of the ping pong ball, that the two mediums of air and water, that due to this density differential, that there is only an air weight possible to achieve, as the ping pong ball has no downward vector weight force in the medium of water. So the ping pong ball has weight in air, but it only has mass in water, but it also only has inertia in air. You see, you can't define mass as having weight or inertia, as technically the ping pong ball has no inertia in water because it won't stay in the water. It will only float on top of it without the addition of an external force. So it can't resist an acceleration in water because it won't stay in water, only on water. What I mean by that before I just move on is we can't make gas stay down on the ground as like a solid or a liquid that's contained. We can't do that. Gas won't do that. So it won't exhibit inertia. It will constantly do its own thing. No more than you can make the ping pong ball stay down underneath the water without holding it down within your hand. The only way you can make gas stay on the ground and stay down is to contain it in a container. That's it. Other than that, it's doing its own thing. It's moving in every direction possible. So what I mean by this ping pong ball example is that the ping pong ball has no weight in water. So it can only be called a mass. It has no weight. If you want to call mass, weightless, then you can call a ping pong ball a mass in water. But if you're stating that mass is inertia, then the ping pong ball is not a mass in water. You can't call that a mass at that point. No more than you can call the air we breathe a mass. If you're going to call it inertia, you can't do that. One doesn't equate to the other. Inertia requires a weight. So to call mass inertia, you're saying that mass already has a weight. So you can't. And how is weight defined? It's defined as a linear downward vector, and it's calculated within air. So how can air be calculated to have a linear downward vector? Something it won't have due to its natural behavior anyway. How can you do that within air itself? Air is the medium that you're weighing it in, so you can't attribute a weight to it. So you can only call something mass if you're going to also claim that is describing it as weightless, as having no weight. And if you can't weigh it after that, then it must stay as a mass, unlike the steel ball that we can weigh. Then you can say that has a particular weight in air, it's air weight, or it's water weight, or whatever. But you can't do that with gas. So gas can't have a weight, and gas doesn't resist acceleration, so it isn't inertia. It is acceleration. It's always accelerating. So gas is not a weight, and it doesn't have inertia. So if you want to call it mass, if you want to call a gas mass, then you're going to have to state that mass is weightless, and is a description of weightlessness. It's just a description of stuff, a density of stuff, without any conventional weight. So I'll move on. People confuse density with inertia, as air has density, but it's not technically resisting acceleration, as it's always accelerating. That is its natural behavior. So when someone finds that they can't walk into a wind during a storm as it's too strong, the air and wind is not resisting acceleration. The person trying to walk into the wind is the one resisting acceleration, as gas is always accelerating. It's the same for an airplane that flies through the air. The air is not resisting the plane, as the air is accelerating whether the plane is there or not. It is the plane that resists the air, and not the other way around, or a 50-50 balance. Gas is the acceleration that all solid objects and liquid substances resist. As it's always moving, that's what it does. It accelerates. And all solids and liquids have a calculated downward vector weight within the medium of gas. But this is not strictly true for them within other mediums, and it's not true at all for gas, as gases can't have a weight within the medium of gases, as that's impossible. Gas cannot be mass if mass is defined as having inertia, as gas does not exhibit inertia or weight, and inertia requires weight to resist acceleration. Gas can only be termed as mass if mass is termed as weightless, as gas has no conventional apparent singular downward vector force of weight, as gas is the medium that other things are weighed in. Gravity has not been termed a force, but an effect, since Albert Einstein's colloquial theory of general relativity was published and accepted in 1915. So outside of density differentials between mediums, objects and substances, there is no other explanation for the convention we call weight. Thanks for watching.